Class extensions are something many new to Unity or development in general haven't heard about or aren't really familiar with. Yet, they enable us to beautify our code and make everything way more readable. They further help us to work with common programming principles like build it once, use it forever, and if you made a mistake, you only have to change it at one place. With that said, hello and welcome to I Create My Games. I'm Jens, and in this episode we're going to talk about extension methods. Let's first take a closer look at the definition of extension methods. Extension methods enable you to add methods to existing types without creating a new derived type, recompiling, or otherwise modifying the original type. They are static methods, but they are called as if they were instance methods on the extended type. In short, this means once an extension method is created, it can be called just like any other class method without changing the base class. Now let's take a closer look at the syntax. First of all, the method has to be static. I usually like to place them in a static class as well, but that's just a personal preference. Then the thing I want to extend has to be the first parameter with the this keyword. So if I want to extend the string, it's this string variable name. Besides that, they work pretty much the same like any other method would. So you can add a parameter or return values or whatever you like. You can even make them private, which would be a bit of nonsense, but it's still working. Let's take a look at a specific implementation and how we would do it. Now, if you ever worked with images or colors, you know that you can't simply change the color of an image directly. So if I would try to go with image.color.a and try to assign the alpha value, the compiler will tell me, well, it's simply not possible because it's a struct and therefore I can't. So if I want to change the alpha value, I need to copy the color, change the alpha value of the color of the copy, and reassign the copied color. These 3 lines of code aren't that problematic, but you always have to write these 3 lines of code if you want to do it. So one possible way to make it a bit more streamlined and a bit more readable would be to create an extension method for the image to change the color. So that's what we're going to do. So first of all, public static void change color alpha for this image. Now keep in mind, image is part of the UI class, so it has to be included. And float alpha. And here we can simply use these 3 lines of code. Put them here, and now we can always call this method instead of our 3 lines. So I can simply go with image.change color alpha. I can see it's an extension methods with the line on the side. And if I now add the alpha value, it works exactly the same before, and it's way more readable. Another thing I like to extend but doesn't really work generically would be enums. Now imagine we have a function which gives us a value if I have to work in a day. Have to work, and it receives a day of the week, which is a standard enum of C#. And here I could go return false, and if day equal day of the week Monday, or day equal day of the week Tuesday, and so on, and return true. This does work, but it's really not that readable in my opinion. So we could instead use an extension methods for day of the week. We simply go over here and go with public static bool is work day, this day of the week day, and here we can simply use a switch to get the last out of performance, switch on day, and again return false in this case and return true in this. Now we can use the fall through of our switch, and on these days I have to work. And now if I have to know if I have to work, I can simply go with a more readable way, like return day is workday. As I said, this doesn't really work generically, so I have to create something for the enums I'm using, but you could easily apply it to different enum, like enum, let's say we have directions, up, down, left, right, up, left, up, right, down, left, and down, right. And with these, I want to know if it's a normal direction, like straight up or straight left, or if it's something in between. And again, I could simply create a simple method to do exactly this. Is middle direction. Use the direction, of course. Dear. Again, switch it. And go with the same syntax. So return true. Use the fall through. And I now can, every time I want to call it, go with dear dot is middle direction, if I want to know if it's a normal or something in between. Now, over the time of being a developer, I had the possibility to collect a few different extension methods, all with their own purposes, but not all of them are really useful for everyone. So let's go over them, and you can decide for yourself if you want to copy them or not. First of all, color extensions. Color extensions pretty much work the same way we just saw. I have one extension method for the image and one for the sprite renderer. I didn't want to include the UI library, so I simply wrote it like this. It's totally viable. And I have one to change the color or to get a color with changed values. Now, with this, I can, as you see here, change one specific parameter of the color. It can be alpha, it can be red, green, blue, whatever. It can be multiple, so I can go with R, it will be 1, and it's possible as well. Now, first of all, how this works. It makes use of the double question mark operator, which is a great way to reduce the overall source code, but it can, if you're not familiar with it, totally derail your concentration because you don't know what exactly it means. So first of all, it checks if the given value, first value, is null. If it's null, then it goes to the next next value. So it checks if it's null, and if it's not null, it uses this value, otherwise it goes to the next one. So since I'm not using float, but float question marks, which are able to use null values as well, I can simply verify if this is null or not, so if it was given in the method or not, and then use it or use the previously used color. And this goes for every single one of them, red, green, blue, and alpha. Next up are the, let's go with the vector extension because they work pretty much the same. I have one for the vector2, which does exactly the same with the double question mark operator. The same one for vector3 down here, but also a one or multiple for different situation where I want to increase the current vector by something, or multiply it by something, or rotate the current vector. And the same goes for vector3 as well. It's pretty much the same, but with z. And I can add values, I can multiply values, and that's basically it for vector and vector3. Next, let's go with, let's say, the transform extensions. The transform extensions are all extending the transform of our game object. So as you know, inside any C# script, we can simply go with the transform parameter and from then do something specific. So I have one to loop through all children, recursive, and get the transform with the specific name as a game object name. Now this is useful for me because it doesn't verify if the transform is active or the game object is active, which if you're ever using the find method of GameObject.find does. Now this can find a transform which isn't actually active, but the find method of the game object doesn't. Now keep in mind, since it's looping every single one, it can be rather taxing on the performance, so only use it in a lower level of your hierarchy and not in the top level. Now print all children is just the wrapper for my print all children private method, which uses a plane to kind of lock these children depending on which plane we are. So if I use it, I can simply write multiple parts of the hierarchy into my console, or with a little bit of information in front of them, so I can see, oh, this is another plane. Then the destroy all children is, just as the name suggests, loops through every single children I have on my current transform and destroys the game object attached to that. So if I ever want to kind of clean up below that, I can do it with this. I often use it when I have an obstacle or a situation where I spawn obstacles dynamically, and I usually parent them to container, so I can, whenever I have to clean them up, simply move with this transform through every single child and destroy all of them. Now the next one, get component and check children, is a method to recursively check for a specific component. Now if I have, for example, a sprite renderer not on the top hierarchy, but later down in the hierarchy, with this method I can collect it. Now the same one applies if I have more than one of the type, but then I have to use another method which works pretty much the same but returns a list with every single component of that type. So get all component including children loops through the current transform, every children of the children, etc., etc., to give me every single instance of the component currently attached to the whole tree I'm starting with. And then I have one to reset to initial, which can either be for local or for, well, global, where I change the local scale, the local rotation, or the local position to the initial values. Now there isn't a scale overall option, so even if I'm not going for local, I have to change the local scale, or I would have to loop up or something like this, but this is what I want to usually do. Next, let's maybe switch over to the GameObject extensions. Here I have one option to ask for a component and verify if the component exists. If it doesn't, I simply tell the console, well, it simply doesn't exist. So with this, I now don't have to check for the if the component is null inside my script. So in the start method, I can simply go with get component required, and it checks and writes if the component doesn't exist. Which does exactly the same, the next one, but it has a callback action. So if I have this component, I want to do something with this component. Now the action is a delegate action and not a unity action because they are faster, and you will see it in a later point. I used them quite a lot. Now pretty much the same, get component, but in this time I have a success and a failure action. So if I don't get the component, I can still either print something or do something else entirely, maybe add the component or do something else. And to other options which we discussed before, which only link to the transform option to get these component in the children. Next, let's go with the float extension because they're pretty small. I have exactly two methods here. The first one is asDigitalTimer. So I can format a float in seconds as a digital timer. Now, floats in seconds are used pretty often in Unity. Time dot, for example, real time since startup would be one possible way to create a timer on top of somewhere which doesn't even consider the time scale or something like this, or we can simply go with the delta time or whatever you want to actually format as a timer can be, as long as it's a float, can be formatted with this. Now, first of all, the parts have to be calculated. So I use a float to int method, which does exactly what it's writing there. It returns an integer smaller or equal to f. So if it's 1.5, it returns 1. If it's 1.9, it returns 1 as well, and so on. And with these methods, I get the part I'm currently looking for. And then, depending on the time unit, the maximum time unit, I write the parts I want formatted and either 2-digit for seconds, minutes, hours, or days, or 3 digits for milliseconds. Now the time unit is an enum I created myself with only these few values. The other method would be the map method, which maps from one range to another. So if I have a value 50 in the range from 1 to 10 and map it to 1 to 10, it will be 5. So with this, I can change ranges pretty easily. I have the same one for integer, but that's in another extension class. Next, let's go with the AudioClip extension. It has 3 shorthands for one method. This method creates a one-shot audio, as it's written here, at a specific position with a specific clip with the clip selected and the volume, pitch, and pan I'm using. And it also destroys the object once it's completed. So with this, I can simply create an audio source anywhere if I only have the audio clip. So I can create a clip manager which holds all the clips I'm using, or go into the resources and load an audio clip or whatever I want, and simply create it at a specific point, or just create it if I don't want to specify a point or something. Next up, let's go with the array and list extensions. Pretty straightforward. Shuffle is just a possibility to shuffle a list. Now I'm using iList and not the list object because this is an interface which is included in multiple list types, which also includes an array itself. So I can go with, let's say, an integer array, a equal 1, 2, 3, 4. And now simply go shuffle, and it still shuffles that array. So if I include the interface instead of the explicit object, in this case, I can do whatever I want with this. Now, the next one is add multiple. So I can extend a list by more than one in one line of code. So I could, for example, have list a equal new list int, and now go a at 1, a at 2, a at 3, or I could otherwise go simply with add multiple and 1, 2, 3, and it does exactly the same thing, which works pretty well, I think. Now, next up, enqueue multiple is pretty much the same, but works with the queue because I like queues very much. They work with a different principle, and you can't access them that easily, but you work here with the first in, first out option, so I can work with a similar situation. Now, the do for each is one I like especially. I will demonstrate it real quick. a again, which would be 1, 2, 3. And now with the do for each, I can call an action for each and every one of them. So if I have, for example, a sum, which is 0, and a dot do for each, I go with value sum plus equal value. I can now sum this. Now there is, for example, in the link methods, there is a sum method as well, and there are different possibilities, but this doesn't only applies to arrays, but to lists, and to I can pretty much use any possible action I want. I can write something with each and every one of them. I can do a whole lot of fun with this, just with a little shorthand. Now next, random item. Pretty much the same. It just gives us a random item from the given list. Now, again, not only lists, but also arrays and everything using this interface. And remove random does the same as random item, but also removes it from the list. So if I have like 5 options and I need to decrease the list, every time I go with this option, remove random. And one to as a shorthand for the string.join operation, so I can use it on any list by default. So previously I always had to write, I will go with again my beloved integer list, 1, 2, 3. And previously I always had to go with string, join, and a and oh no, the separator first, which would be something like this, and a. Now, if I remember this, everything is fine, but I tend to forget it, to be quite honest, so I wrote a shorthand, which I can now call with this little option, and just use the separator in here, and it does exactly the same. And since it's in the completion menu, I don't forget it anymore. Pretty neat as well, I might say so myself. Now let's switch over to other extensions. These are extension I couldn't order so far, so they're just, I didn't save. So I just put them here. The first is between, so I can call with anything I have, my integer value a equal 1. And now I can ask a is between, let's say 0 and 1. And also decide if I want to have it included the upper and lower border or not. So I always wanted it because in SQL it's possible with a simple operator, but not in, or by default, not in programming. So I wrote this one so I could make it a bit more SQL-like. The next one, pretty much the same, which works like the SQL in operator. So again, my 1 and a dot is in. And this time it's not just 2 values, but as many as I want. So I can give it a list and verify if it's one of the lists. So this works, but it would also, of course, work if I go with a list which is predefined, or a const list, or something like this. So I have an easy is inside or is in list variation, pretty similar to the in operator in SQL. Now the map function in integer, I already told you about it. And then one for enums, which gives me a random value of the enum. So if, where is it? I have, let's go with the time unit, which is the enum I created myself. Tu equal time unit dot, let's go with hour for the moment, And from now on, I can simply go with tu equal tu dot make random, and it simply gives me a random value. So if I need to maybe have a starting direction with an enum or something like this, I can simply decide which one I want with a very simple random variation. And that's that. And now, last but not least, the string extensions. First up, get deterministic hash code. Now, if you know the hash code method of the usual string, so get hash code, I once was under the assumption that this one was deterministic as well. So it would give me the same hash code every time I put in the same string, but it simply doesn't, because something I read it in an online forum, and I can't recall the reason, to be honest, but I also found a solution for it, which someone posted, and so now I have a deterministic hash string function. I use it, for example, to create a seed for a random game from a string. So maybe the input name is the seed or whatever. Now in this, the formal is, well, I just copied it, so I don't know exactly what it does. The important thing I had to do was the unchecked variant, which means if my integer has an overflow, normally my integer would throw an exception. With the unchecked, it simply loops around, and this is exactly what I needed. So with this, I get a deterministic hash code every time the same with the exact same string. Next to clipboard, in every Unity program, it's possible to copy the current string to a clipboard with the text editor. Now, this is something I used for my labyrinth, where I created a text value and didn't want to write the text in any TextMesh Pro component or something, because it wasn't uniform for every single character, so it would look pretty weird. And with the toClipboard method, I could post it in Notepad and simply had a uniform same length for every character, and then my labyrinth didn't see that, didn't look that weird. So now I have it as a string extension. Now log to console, just pretty much like the name suggests, I can go with everything I have as a string. So if I go with a to string, I can now log it to console and choose if I want to do it info level or maybe error or warning. And again, this enum is something I created myself. It has these 3 values. Let's just show them for a moment. Next up is the count occurrences. Count occurrences gives me the amount of times maybe space or whatever is inside my string. So if I want to know how many words are, words not exactly, but if I want to know how many of anything exists in my string, I can simply use this one. Again, a shorthand is null or empty, because string dot is null or empty. I tend to forget it, and so I created one I could use on any string. So is null or empty can now simply call it like this. Next, word count, similar to needle, but a little bit different, since I split on different characters. Now, if I want to split on more than these, like for example, I don't know, let's say a plus or some parentheses or whatever, I can still do it. I just have to give the options to my function, again with the double question mark operator. Repeat uses a string builder to repeat this the string over and over again. I don't think it needs much explanation. Now convert to X are a few conversion possibilities to work with the string. So I don't need to remember that I have to check specific things. like to Enum, if I have a value in my, if I have a string value, like the log level error, which I have shown, so it's error, I can now simply go with error dot to enum, go with debug log level, and now have it as a real enum value, which I could then in turn use for specific other things. The same goes with float, which can also give a default value. If it doesn't, if it's simply not parsable. The same for an integer and for a boolean. Now for a boolean, I extended the try-parse method, so I can use 0 and 1 and false and true as well. So f and t, false and true as a written word are already in the normal try-parse. Now, a little bit more complicated, the decryption or encryption in this case, where I can encrypt any string to represent a simple, just use it as a simple RSA, I think it's called, RSA encryption. Yes, and use this to maybe store my information or something. Now for this encryption, I also have the decryption, which uses a key as well, and goes through the logic. I again didn't write these, I just simply copied them and used them in a project I was working on. So now I have them every time I need them. And I think that's it. We went through all the extensions. I do encourage everyone to really write them down, because learning can be done in different ways. Like hearing is one way, seeing is another, and really getting involved is the third and most important one. So with this, with writing these, it's simply a better way to know what these methods will do, so you remember that you can use them. Now, I've said that, and I think that's still a good idea, but I think I might also be able to be persuaded to just post the code online. But again, I think I would start with writing them, because then you really know what you're doing. And that's it for strings extensions. Now, if you have any questions left, always feel free to comment. I'll do my very best to answer them as quickly as possible. Thank you guys for watching, and I'll see you next time.